Hello viewers, in today's class we are going to discuss an important problem from Lagrange Mean Value Theorem, and here I will verify Lagrange Mean Value Theorem for this function f of x is equal to e raised to 4x in the interval 0, 4, right? So let us start. So now we see that this function is exponential function, right? So the function f of x, that is e raised to 4x, is a continuous function in the interval 0, 4, right? So this is the first condition for Lagrange mean value theorem, that is the function has to be a continuous function in the closed interval, right? So here the interval is 0, 4, and we know that the exponential function, that is say f of x is equal to e raised to x, is a continuous function for all values of x belonging to the set of real numbers, right? We can also prove the continuity of this function by separately finding out the left hand limit and the right hand limit, and then equating both the limits, that is the left hand limit and right hand limit, and then finding out the value of the function at the given point, right? Okay, now let us differentiate this function f of x. So f prime of x is given by 4 times e raised to 4x. So the derivative of e raised to 4x is 4 times e raised to 4x, and we can easily see that this function is a differentiable function in the interval, that is the open interval 0, 4. And again we can prove the differentiability of this function by separately finding out the right hand derivative and the left hand derivative, right? So the function f of x is continuous and differentiable, so there must exist some point c between these 2 points, that is c should be greater than 0 but less than 4, such that the derivative of this function f of x at this point c should be equal to f of 4 minus f of 0 divided by 4 minus 0, right? Because from Lagrange mean value theorem we know that f prime of c is equal to f of b minus f of a divided by b minus a in the interval a comma b, right? And here a is 0 and b is equal to 4. So now f prime of c can be written by replacing x by c. So we have 4 times e raised to 4c is equal to f of 4. F of 4 is e raised to 4 times 4 minus f of 0 is e raised to 4 times 0 divided by 4, right? So we have 4 times e raised to 4c is equal to e raised to 16 minus 1, because this term is e raised to 0, e raised to 0 is 1, and here we have 4, right? So now we have an equation in c, and we have to find the value of c from this equation. So now let us write this equation as e raised to 4c is equal to e raised to 16 minus 1. Taking this 4 to the denominator, we have here 4 times 4, that is 16. Now let us take the natural log of both sides. So we'll get ln e raised to 4c is equal to ln e raised to 16 minus 1, and here we have 16, right? So this is 4c times log of e, and here we have log of e raised to 16 minus 1 minus log of 16 by applying the properties of log. So here we have applied these two properties. So log of e raised to 4c, we have applied this property, and we have written log of e raised to 16 minus 1 over 16 like this, using this property, right? So now log of e is equal to 1. So here we have 4c simply, and here we have log of e raised to 16 minus 1, and log of 16 can be written as log of 2 raised to 4, that is equal to 4 log 2, right? So here we'll write 4 log 2. So now viewers, here we have log of e raised to 16 minus 1, right? And if we see the value of e raised to 16, then this is a very large number, right? And then we have to subtract 1 from e raised to 16. So e raised to 16 minus 1 is a very large number, right? So what we will do here, see here we have e raised to 16, and e raised to 16 is this number which is very large as compared to 1, right? So what we will do here, we can neglect this negative 1 with respect to e raised to 16, right? We'll also see the another aspect of this calculation, but let us first see the situation when we neglect minus, that is 1 with respect to e raised to 16, right? So e raised to 16 is very large as compared to 1. So let us neglect 1 from e raised to 16. So we can now write log of e raised to 16 minus 4 times log of 2, right? So this is 4c, and here applying the property of log, this property we have 16 times log of e minus 4 times log of 2, and log of e is 1. So we have 4c is equal to 16 minus 4 times log of 2. So now let us solve this equation for c. So c is 16 minus 4 log 2 over 4, right? So taking 4 common from the numerator, here we have 4 times 4 minus log of 2 divided by 4. So this 4 and this 4 get cancelled, and we are left with 4 minus log of 2. So the value of c is 4 minus log of 2. So now the value of log of 2 is 0.693, right? So the approximate value of log of 2 is 0.693, and if we subtract 4 minus 0.693, we'll get 3.307, right? And this value, that is 3.307, it belongs to the interval, that is the open interval 0 comma 4, right? So the value of c in Lagrange mean value theorem can either be given by this expression, that is 4 minus log of 2, or 3.307. So viewers, let us see the another aspect of this calculation, right? So earlier we have neglected this 1 with respect to e raised to 16, because e raised to 16 is a very large quantity as compared to 1, right? And we obtained the value of c as approximately 3.3, right? And now let us consider the situation when we do not neglect 1 with respect to e raised to 16, right? So in that case, what we will do, see, we have this expression, c is equal to 1 over 4 log of e raised to 16 minus 1 over 16, right? So what we will do, we'll take help of logarithms, right? So we'll take e raised to 16. It means we have to separately find out the value of this expression, that is e raised to 16 minus 1 over 16. So what we will do, we'll take y is equal to e raised to 16. So just for saving the time, I have already written all these calculations here. So e raised to 16 will take it as y, taking the log of both sides, that is to the base 10. We have log y to the base 10, and here we have 16 times log of e to the base 10, right? So taking the help of the log tables and the values, we can find 16 times log of e to the base 10 as 6.9479, right? So now here we have log of y to the base 10, right? So now y can be obtained by taking the anti-log. So we can take help of the table, anti-log table. So the anti-log of 6.9479 is this number, and then this is the value of y, right? So now we have taken e raised to 16 as y. So this is y minus 1 over 16, right? Okay. So now y minus 1 over 16 is this quantity. We'll subtract 1 from this one, and then we'll divide the difference by 16, and then we'll get this number, right? 554344.8. So now in all these calculations, we have taken the approximate value of E as 2.718, right? So now we have y minus 1 over 16 as this number, and now we have to calculate the log of the natural log of this number. So the natural log of this number is 13.23, right? So we can convert this natural log to the base 10, and then applying the known values, we can get 13.23, right? So now the value of c is 1 by 4 times log of y minus 1 over 16. So we have 1 over 4 times 13.23, right? So when we divide 13.23 by 4, we'll get 3.3075, which is almost equal to the value of c, which was calculated when we neglected 1 with respect to e raised to 16, right? So by this calculation and by the earlier calculation, we can easily conclude that there is no harm in neglecting this 1 with respect to e raised to 16, right? It means e raised to 16 minus 1 can be approximated as e raised to 16 for our calculation, right? So if we make all these calculations, we'll arrive at the same result with a very small difference, right? So from both the methods, we'll get the value of c as 3.3, right? Approximately 3.3, and this 3.3 belongs to the interval 0 comma 4, or we can also express this 3.3 or 3.3075 value by this expression, that is 4 minus the natural log of 2, right? So this is how we can verify the Lagrange's mean value theorem for this function, and I must say that this was a very nice problem.